Hey guys, so this is section 11.1, one-way ANOVA, and this is question number 8. All right, so I downloaded already the data, and essentially the data is for 9 countries. It's showing the data of the import across 4 global regions, right? So what we're gonna call this one, the average is gonna be mu1, the average here can be mu2, mu3, and mu4. And what we want to figure out whether all these means are equals or not. So this is our hypothesis, the null hypothesis 8.0. And just for a small review, so your null hypothesis in this case for one-way ANOVA is going to be this statement. 8.0 is going to be all the means are equals, and H1 is going to be at least one of them is different, or not all of them are equals. All right, so I think the statement is clear, and it will be A in this case. Let's check it. All right, great. Now they're asking about the F statistics, so I need to run the test, and let's get rid of this. All right, so in order to run the one-way ANOVA test, you need to go to data analysis, and then you go all the way on the top. You can see ANOVA 1 single factor and say OK. So we're going to choose all the table, including the headers. Once you select the table, you're going to select the labels. The alpha, you change it if you need it. This is 005 is fine. And the output, we're going to put it in the same spreadsheet. So we can select a cell there, and that's all. Okay, we get the results, and the F statistic will be this one, 3.49. Copy, paste it, and round to 2 decimal places, right? Okay, we got it. Here they are asking about the p-value, so the p-value is the value next to it. Let's copy it and paste it as well. And this should be 3 decimal places, so you're going to be 0.26 instead of 6. You're going to be 7. Okay, so here let me go back to note. I'm just going to, all right, so for this one we have the chart here, and what we are comparing, either you compare the F value with together, or you compare the P value with the alpha value. All right, so let me try to explain it rapidly here. So this is where the F alpha is lying. So this is the value of the F alpha. So the right side is going to be considered the rejection zone, and the left side is going to be considered the no rejection zone, right? So always we are talking about 8.0 here. So reject and do not reject 8.0. Okay, so the F alpha, this is what we call the F critical, and the F critical is given to you by, this is 2.90. So this is 2.90. So this is our reference, right? If I'm on the right side or left side, then what I want to do is I want to look for the F stat, and the F statistic is 3.49. so if I draw it here, and this is 2.9, the 3.49 should be somewhere here, right? The F stat, this is 3.49. okay, so do you see the F statistic is located on the rejection zone, right? So what you're gonna do, you're gonna reject 8.0 then. So the statement that we have here, if F stat is greater than F alpha, all right, you reject, otherwise do not reject. All right, so now what this has to do with the alpha and the p-value. So the alpha is obviously, let me see, all right, the alpha obviously is over here, that the shaded area, all the way the tail, right? So where the F alpha or the F critical stop, the alpha stop, that's the area of the alpha. Now, on the other hand, what we have, the F statistic is right here. So you're gonna form as well another tail, and the tail on the left side, that's what we call the p-value. So if the p-value is small, what's gonna happen? You're gonna reject. So equivalent statement to this, p-value smaller than the alpha value, so this is gonna be reject. Otherwise, you do not reject. All right? So I hope this is clear. So this statement, the green statement here, is equivalent to the green statement over here. All right? Okay. So we are rejecting. Every time you reject, you have enough evidence. So I am rejecting, or I have sufficient evidence at the level of 0.05. All right? Reject sufficient evidence, and do not reject insufficient evidence. I hope this is clear. So in this question, since they are asking about the East Asia and Pacific region and the Eastern Europe and Central Asia region, so whether they are different or not, all right? So you are supposed to do the test, all right? So we are comparing basically the East Asia and Pacific, this column, all right? And the Eastern Europe and Central Asia, all right, this column. So mu1 and mu2, whether they are the same or not. All right, so to do this, again, what you need to do is you need to do the Tukey Karmer procedure. And this is a kind of a long procedure. So you will need to calculate the critical range. You will need to calculate the absolute value of the difference of xj's, all right? And there is a few steps to do. So the book here is providing you with this table. So I'm gonna duplicate this table and do all the steps at once, all right? Okay, hang in there. Okay, so I just duplicated this table here, all right? So you can see here, I did the groups, sample mean, and everything ready to go, right? Okay, let's start with one step at a time. So the first step here, I wanna get the level of significance. Okay, the numerator degree of freedom. So this you can get it from here, the degree of freedoms, right? So you have degree of freedom is, well, is not 3 really, is 4. We have 4 here, 4 columns, all right? And the within groups is 32. So 4 and 32, right? So this is gonna be a 4 here, this is gonna be a 32. So the mean square within groups, you get it from the table as well. So this is the mean square within groups, which is 8,000 something, no, 87,000. So we're gonna put here equal sign, then we go all the way and we select this, enter. Okay, now we have the Q statistics, right? So it's not the critical yet, we are doing the statistic one. So since we get 4 and 32 are the degree of freedoms, numerator and denominator, so we're going to be using this table here, right? So the critical value standardized range Q table, right? So we're going to follow the 4 all the way to 32. So there is no 32, so 30 should be enough. So 3.85 is it? Yeah, 3.85. So what I'm going to do, follow the 4 again, and that's going to be 30, 385. So I'm going to put equal sign again, and I'm going to select it. As you can see here, as I copy the as values as well, one of the options. Enter, done. All right, so once you've done this, you want to calculate the critical range, right? So now how do you get the critical range? You have the formula right here. So this is going to be equals to the Q alpha, which is 3.85. And then you're going to multiply it by square root SQ RT, open the parentheses. So the MSW, which is the value of this one, divided by 2 and multiply it, open the parentheses, 1 over, right, the NJ and NJ prime, actually the size of the groups, and they are odd 9, right? So 1 over 9 plus 1 over 9, all right? That's how many countries we are counting, right? How many rows in here, right? So you see, counting the number of rows is going to be 9. And that's all. I'm missing parentheses, but it's fine. So you're going to be 380, all right? That value there, it will be the critical range here. So I'm going to put equal sign and copy this one, and I'm going to lock it with F4. There you go. For me, it's function and F4. All right. Okay. So once I get this one, so I need the rest in here, the same values, and then I'm going to start on working on my table. So the groups here, group 1, I'm going to select it equals to the first one here. All right. Group 2, you're going to be the second one. Group 3, you're going to be equal sign Latin, and all right, group 3 going to be the Middle East and North Africa. Okay, so I define my groups. Now what I'm going to do is the sample mean for each group, right? So now the sample mean, actually they are given to you on the ANOVA test. So these exact values, and they are in the same order, all right? So the only thing you gotta do, equal sign, click on the first one, that the average here, enter, and if you drag this one as well, the rest you can be dragged. Okay, so you see these values here are the same as the averages, right? Now we have here a sample size. We know sample size is 9, so you can do equal sign and 9, that's count, all right, and you can drag it. Okay, so what we're gonna do here, we're gonna put equal sign, absolute value, ABS, and open the parentheses. And since you are comparing group 1 and group 2, so you're gonna do group 1 minus sign and then group 2. Close the parentheses and enter. And then you're going to do again absolute value, ABS, and then since you are comparing 1 and 3, you're going to do 1 minus the third group, and again equal sign, absolute value, and this is group 1 and 4, so this minus the last one. Okay, now we have group 2 and 3, so you're going to be equal sign, absolute value, and we're going to do the second one, this one, minus the third one, this one, and enter. And then this is going to be equals absolute value again, and 2 and 4, so the second one minus the fourth one. And the last one, you're going to be between 3 and 4, so you're going to be equals absolute value, and then you're going to be between the third minus the fourth one. Okay, that's the third minus this one, the fourth. Okay, we get all the differences. So what's going to happen right now, we're going to compare those absolute values with the critical range, right? So we're going to make a statement, if statement. So equal sign, if. Now, if I have the absolute value greater than the critical range, then my statement will come up, the means are different. All right. Otherwise, right, so otherwise I go inside the semicolons and I say the means are not, this is the alternative statement, different. So what does it mean? If the absolute value difference of the absolute value of the difference is bigger than the range, then I'm going to say they are different. If the absolute value or difference of the absolute value is greater, then there is a proof that they are different. All right, so enter. So the first one is giving me no, they are not different, and I'm going to drag this one all the way to the fourth statement. So the only difference here is the difference between group 2 and 3, and it happened to group 2 and 3, they are Eastern Europe and Certain Asia and Latin America and Caribbeans. They are the only two difference. So your statement here, the first one is going to be no. All right, the only two groups I'm looking for, they are different. So what they are saying here, is there significant evidence that the East Asia and Pacific region and the Eastern Europe and Central Asia region are different, all right, differ from in mean cost. All right, so this one is saying no. I'm gonna check it again. The only proof I have between Latin America, Caribbeans and Eastern Europe. All right, so if I don't see Eastern Europe and Latin America, my answer would be always no. So East Asia and Latin America, that would be no again. Now East Asia and Middle East will be no again. And this one, Eastern Europe and Latin America. All right, let's see. Eastern Europe and Central Asia, that's the one, and Latin America, that's the second one. And they are the only group, they are different here. All right, that's the group I'm looking for, 2 and 3. Okay, so yes, we have proved that they are different. Okay, now we have Eastern Europe and Central Asia. The answer would be no. The only yes was only 2 groups. And did we finish? No. Again, another no. Okay, all set. Okay, we are moving to compare right now the variances. All right, so that's another test that we run to figure out whether our calculation is correct or not. All right, let me go back to the correct section, and that's going to be Levene test for homogeneity, right? So the test is going to be always having the same statement, whether all the sigma 1 squared equals sigma 2 squared and so forth. This we're gonna get up to 4, and not all of them are equals, right? So this is always the same. Okay, so the equivalent here is gonna be up to 4, and not all of them are equals. Yeah, this is going to 9. This is gonna be B. Now they are asking you to run the test and figure out what the value. Okay, so let me go to the test. So what I'm going to do, I'm going to duplicate this table. All right, so this table is looking for the median for each one of the columns. All right, after you find the median, once you find the median here, all right, you're going to take each value, right, the first value minus the median, second value minus the median, and so forth. And then you take a median for a second row, a second column, and you're going to do the same thing, the first value on the second column minus the median, and so forth. And you do the absolute value, of course, right? So this is going to constitute another table. Once you run this table on an ANOVA test, it's going to give you the F statistics, right? So let's try to do it. Okay, so this is my table. I'm going to start with the median. All right, so this one is going to be equal sign MED, and you see the median there. You choose it and select other values. Once you get the first one, you're gonna drag it horizontally to get the remaining values. So to double check, double click on any one of them and it should cover all the values above it, right? Okay, once you get this one, I'm gonna copy the table again one more time, paste it there. So I'm gonna clear the values here and I'm gonna start my calculation. So for the first cell, you're gonna be equal sign, and I'm gonna do absolute value again, open the parentheses, and you're gonna make a difference right now with the first one minus the median. Close the parentheses and enter. So once you get the first cell, you could drag it horizontally but not vertically. So this is gonna give me the other values. All right, so double click, we see it's clearly making a difference about both of them. Right, now I'm gonna go back to the first cell, double click, and I highlight or I select the last cell, the red one, which is the median, and then I'm gonna lock it with F4. So you can see the dollar sign before the letter and the dollar sign before the number. Enter. And once I fix that cell, I'm gonna drag it vertically right now. So what happened in here, click on any of the cells. So you should see, I mean, the third one from the bottom minus the median, and we have absolute value. That's what we want, right? I'm going to do the same action again with the second one and so forth for all 4 of them. So hang in there. Okay, once I modified the cell, I can select them, the 3 together, and then drag them, and I will get the values. Just to double check, click on any of one of the cells. That's what you should do. The third one from the bottom with the median. All right. Okay, we are almost there. So now I'm gonna run again the ANOVA. So I'm gonna go to data analysis, and one single factor. And this is gonna be, again, I have to select this table, the last one I worked on. Labels is fine, 005, and you select the output cell. So the output cell is gonna be, put it there, got it. Okay, so what we want this F value. Okay, let's go and paste it and round it to 2 decimal places. Okay, we got that one. Now the P value, which is next to it, 3 decimal places, so it's going to be a 4 there. So the p-value is greater than the alpha. So greater than alpha, do not reject. So here we are not rejecting, do not reject. If we don't reject, we don't have enough evidence or insufficient evidence. And good. All right, so in this conclusion here, we want to figure out what is the right statement. So this is related directly to our objective, right? So what we are doing here, we are looking for the cost associated to the importing, right, standardized cargo of goods, right? So if we are talking about cost, right? So what you want lower cost for import. So if it is lower cost, then you want to explore that market more, right? So lower cost is good for you and higher cost is bad for you. And since we run our the Tukey test, all right, and we figure out that this is the highest, right? So let me get my drawer. So this is going to be the highest, right? These two are, and this is the lowest. So low and high here, right? Okay, so we know they are different. We have the proof they are both of them different. So if the cost here is the highest one, definitely we want to avoid Latin America, all right? And we want to explore more the Eastern Europe all right, and Central Asia. And while we are there, I mean, the prices here, they are not that much of a difference, right? 359 and 396, they are relatively first and second. So I want to explore as well this one, all right? These two prices here, they are different, although we don't have enough proofs, but still they are one in 762 and the other one 568, all right? So we want to stick with the East Asia and Pacifics and Eastern Europe and Central Asia, right? So reading through this, all right, so here is saying the region Eastern Europe and Central Asia are the lowest cost, so should be considered, right? And that's basically the statement we are looking for, all right? And the region of East Asia and Pacific should also be considered because his import costs are relatively low. That's again the same conclusion we came up with, right? So these two here, they should be considered, all right? And that's basically it, all right? The mean import cost for region of Latin America and the Middle East, they are the highest, and these regions should be avoided. So I will go with A, all right? Now, obviously B and D are saying nonsense statement here. For example, for B, the region Latin America and Caribbean had the lowest. We know it's not the lowest, so we reject that one. C is kind of confusing here. It's saying the import costs of a region Latin America and Caribbean, all right, and Middle East and North Africa were the highest. Okay. However, the conclusion here, these regions should be considered. Actually, if they are the highest cost, how would you consider that? So that's why I didn't choose this statement. All right. So let's check it anyway. Okay, we got it correct, and that's the end of the question. Right, I hope this helped.